Hello and welcome back guys. In this video I would be telling you how to draw function generation, that is how to design a mechanism using inversion method. Now what is inversion method? You have to read from the books. It is very simple that inversion method mostly be designed by using inversion method because it is slightly quicker than other methods. So in this video I would be telling you how to draw mechanism using inversion method. Now if you are new to this channel, please subscribe to my channel by pressing the subscribe button below and please watch it till the end. If you have any doubt, please mention in the comments. If you find this video helpful, please give it a big like. Please check out the links in the description and you can buy Made Easy books at a special discounted price by clicking on the links, and do check out my other videos in the links given in the description. Now starting with the video. So in the previous video I have shown you how to draw function generation problem, how to design a mechanism that is function generation using three position synthesis. Now in this question I would be using the same values, but I would be designing using inversion method. Now how to begin? Beginning is the same. You take AD is equal to any arbitrary length equal to 5 or 6 centimeter, I prefer. Alright, A point is known, D point is known. Now there we used to start from A. Now in inversion method we have to start from point D. We don't have to find relative pole in inversion method. No relative pole is needed. Alright, we have to do it directly. So this is shorter method, inversion method. At D you make an arbitrary length CD equal to, I prefer 3.5 to 4 centimeter. You make arbitrary length. You can take larger, you can take smaller, nothing matter. Your whole mechanism will be correct. Alright, you take AD equal to somewhat length, you take D and you make a arc equal to CD and you make a arc. This is the arc keeping the radius CD. This is also arbitrary length, this is also arbitrary length. Alright, now from CD you measure clockwise 30° and 50°, and you make lines. From CD you measure clockwise 30°, and from CD again you measure clockwise 50°, and you make lines. Wherever it cuts this arc, it would cut at C dash and C double dash, because in our question it was given that theta 12 is equal to 60, phi 12 is equal to 30, theta 13 is equal to 90, phi 12 is equal to 50. These are the angles in degrees. This was the question. That means if input link rotates by 60°, our output should rotate by 30°, and if input rotates by 90°, our output should rotate by 50°. This is our requirement in the question. We have to design for this. Design a mechanism. Alright, now here we have to make at D 512 and 513, 512 and 513, that is 30° and 50°. From CD, that is of arbitrary length, you take an arc, you make angle 30°, you cut, you make angle 50°, you cut. Wherever they cut, this would be point C dash and C double dash. Now join A with C dash, A with C double dash. Join A with C dash, A with C double dash, and you take arc is equal to AC dash, and you make like this. Arc equal to AC double dash, you make it like this. Now how much you have to make? That is the main logic. What? AC dash you have to move it anti-clockwise 60 degree, because theta 12 is 60 degree and phi theta 13 is 90 degree. So you C dash corresponds to 1 2. So you join it by A, you take arc equal to this and you make it up to 60 degree. So this angle is 60 degree. You have got this point. Alright. Now you join AC double dash. You take this rotate by 90 degree anti-clockwise. You would be getting this point. You can name it this point and this point, or you can leave, nothing matters. Main point is ABCD of the mechanism, folding mechanism. Alright, like A, B, C, D. This was phi, this was theta. You have already got C dash and C double dash. You join it by A. AC dash rotated 60 degree. AC double dash rotated 90 degree anti-clockwise. You got this point and this point. Then you join this point with C. This point with C. Alright. You join this point with C. This point with C. Now you make perpendicular bisector of this line, perpendicular bisector of this line. Wherever the perpendicular bisectors will meet, that would be our point B. So my perpendicular bisector for this line, this line is this, and my perpendicular bisector for this line is this. It intersects at B. This is B. Wherever they intersect, that would be point B. And so our mechanism would be A, B, C, D. This is our mechanism. Now whether we have drawn correctly or not, we have to check. That is to verify our mechanism. Now how to verify? You rotate AB by 60 degree clockwise. 60 degree clockwise. Because it was theta at AB. Alright. So you rotate 60 degree and 90 degree. I have rotated AB by 60 degree, AB by 90 degree and named it as B dash and B double dash. Alright. Now BC you measure and take a arc equal to BC. From B dash you cut at C dash and B double dash you cut at C double dash. Now if they cut at C dash and C double dash respectively, that is, you made AB, you made an arc, you rotated it by 60 degree and you rotated it by 90 degree, you measured BC and you take an arc from B dash equal to BC, you cut it at here. If it cuts at C dash, your mechanism is correct. If it, and from B double dash, if it cuts at C double dash, your mechanism is correct. That means I want to say that if BC comes out to be equal to B dash C dash, comes out to be equal to B double dash C dash, C double dash, then only your mechanism is verified and it is correct. Alright. Now this is the inversion method of a mechanism, that is inversion method to draw a function generation. Alright, now if you have found this video helpful, please give it a big like, and if you want me to make other videos on other topics, please mention in the comment section below, and please subscribe to my channel if you want regular updated from my channel, and take care. Bye bye.